We're now going to look at standing waves. We're going to consider the first harmonic of a wave that's fixed on both ends. So we're going to end up with what we call a node at either end. If we have a node at either end, what we're going to end up with is we're going to end up with the wave oscillating from the equilibrium position in such a way that neither end moves. The areas where nothing happens we call nodes, and so if we count those we see that there's two nodes in this situation. And in between any two nodes we're going to have a maxima. A maxima is where we have the maximum oscillation, and in this case there's going to be one maxima. We can also consider the length of the spring or string, which is going to be from the two nodes at either end, and we're going to see, because we have either a crest or a trough, that there's half a wavelength, lambda over 2, at any moment in time. If we go on and consider the second harmonic, n is equal to 2, we're going to increase the number of nodes by 1. So we've gone from 2 nodes to 3 nodes. We still have a node at either end, but we've added a node in the middle. And because between any two nodes there's a maxima, we've also increased the number of maxima by 1. So when we look at this, we can count up the number of nodes, and we will see that there are 3 nodes in this situation, and there are 2 maxima. We can also see, because we have a crest or a trough, that there is one wavelength along the length of the spring. Continuing on, if we look at n is equal to 3, the third harmonic, we're again going to add one node. So now we're up to 4 nodes. So we now have 2 nodes in the middle of the spring. We have one node at either end. And between any two nodes, we're again going to see a maxima. So we've increased the number of nodes, and we've increased the number of maxima both by 1. So now we have 4 nodes, and we have 3 maxima. And now we see, because we have a crest, a trough, and a crest, that we have 3 lambda over 2. Continuing on, the fourth harmonic. Fourth harmonic, again, increase the number of nodes by 1. And so now we have 5 nodes, 3 in the middle of the spring and 1 at either end. And again, between any two nodes, we must have a maxima. So we've increased the number of maxima by 1 as well. So now our number of nodes is equal to 5. Our number of maxima is equal to 4. And we see that there are 2 wavelengths expressed along the length of the spring. This leads us to our general formula for a standing wave that's fixed on both ends. And that is that the number of nodes is equal to the harmonic number plus 1. The number of maxima is equal to the harmonic number, and the length of the spring is equal to n lambda over 2. Carrying on, it's also possible to have a standing wave where we're fixed on one end. Where we're fixed on one end, we'll have one node, but the other end of the spring is going to be free to vibrate. And so we're just going to have one node, and we're going to have one maxima. As before, we can consider the length, but now the length will between the node and the maxima, we're going to see that we only have a quarter of a wavelength expressed here. And if we consider the second harmonic, in much the same way, we're going to add a node, same as we did with the fixed on both ends. And so now we have a node, a maxima, a node, and a maxima. So for the second harmonic, n is equal to 2, I'm going to see that there are 2 nodes, and I'm going to see that there are 2 maxima. Now what we see is that we have 3/4 of a wavelength along the length of the spring. Carrying on, for the third harmonic, again we're going to increase the number of nodes by 1, so now we're up to 3 nodes. And we're going to see that we have a node, a node, a node, a maxima, a maxima, and a maxima. So as expected, we're going to see that there's going to be 3 nodes and 3 maxima, and we can see that there are 5 lambda over 4 represented along this. And for a fixed on one end resonator, what we're going to see is this leads us to our general formula for that. And we're going to see here that the number of nodes is equal to the harmonic number, the number of maxima is equal to the harmonic number, and the length is equal to 2n minus 1 lambda over 4. Finally, primarily with sound waves, we can look at what happens if we are free at both ends to oscillate. And so if we're free at both ends to oscillate, what we're going to have is that n is going to be equal to 1. Now what we get is we get one node in the middle, and we have either end oscillating. So what we have is we have a maxima at either end and a node in the middle. This gives us one node, it gives us 2 maxima, and it's still lambda over 2 like it was fixed at both ends if we consider the overall length, because we see that there's a crest and a trough at any moment in time. So we have lambda over 2. This will follow the same pattern as our fixed on both end resonators in terms of the length, and it will reverse the number of nodes and the number of maxima. So we see that the number of nodes is equal to the harmonic number, the number of maxima is equal to the harmonic number plus 1, and our L is equal to n lambda over 2.